Hello, beautiful people. It's me. Welcome to another practice of mine. Let's start with 5 minutes of typing. Oh crap. Oh. So. Oh, come on. Okay. 8%. Oh well. Is what it is. care of the time, so bye-bye. And here I will go to the next thing. I was doing JavaScript last time, so now I will do what's TypeScript, or what is it? Go courses. So I did this one, and those are the same. So I don't know, TypeScript sounds good. And I have some review. So get user returns undefined. So this will get undefined. One moment. So that name. It's either user or undefined, so this will go to undefined. Okay. Problem is number that got. Yeah. How was this? This one. This one function is number. It should take argument of time unknown. Okay, so it is. So link none. Then there was this output, and that was connected those two things. So it was on. I think is number. Yeah, but I need to do a little bit of tweaking like this. Yep. Now it will work. So here we will open the body and we will return so think that will be the type of something, and it should be equal to the number, like so. Close it. That should be it, I think. Let's try, and it is. Yay! Okay, so avoid undefined. What undefined can't be, so undefined. Find that works. Function that returns nothing, and we have a number that should be number, and we are calling the f. So void is not a number, so this is a type error. And here's a problem. Use the nullish coalescing operator to write a function name or default that returns a person's name, all pilfered if the name is undefined. So coalescing operator is the two question marks, and we will return, and either it will be name, and if it is not defined, we will what will Ford return? Will Ford like this, and that is correct. Defined is, so this will return 1. That's not what I wanted. This will return 1 because this coalescing operator returns first value, which is not undefined and not null. So this will be 1. Then we have a user defined type defined type user. Then we have a function which is getting user, and It's user or undefined type returns type. That's the unification. Yeah, so and we will get user dot name. I'll return that. Okay, so this will return a mirror. Then we have another user, we will return null, so this will return undefined, defined, and 2 times 2, so this is a syntax error or type error. It's type error. So we have an unknown, that is a 5. Then we are checking for the type of n equals number that returns. Yeah. So this one will work. It will return 5. Unknown is equal 5. Then we put it into. Then we point n2, which is na to what to this thing over here, and then we will point this, which is number, to what is inside of any, and that we can, so it will says 5 unknown. This is a problem, this is a type error. We cannot assign, we cannot point the n2, which is a number, to something which was unknown. Something is unknown to make this code stop compiling syntactically, preventing the bug that currently exists. So we'll do this so that works. This function has a bug. So we have a is number. It says an is number and it runs true if it is a string. So this will say that this is a number, it's a number, so it will return that value. So n2 is now, oh no, weird. Bum bum bum. Write some code. Passing test. Write a type for a function that takes a number and returns string. Takes number, returns string. A type takes number, returns string equals, and that will be okay, so it was like this, string, and here it will be number, like so. Well, that is so. Okay, well, good for me. That's the definition of the type. That was it. Okay. Typescript function as arguments. JavaScript functions can be assigned to variables, stored in arrays and objects, and passed as a function arguments. We say that JavaScript has first-class functions. Because functions are first class of part of the language with no special restrictions. Not all languages have first class function. TypeScript can do everything that JavaScript can do. So TypeScript also has first class functions. We've already put functions into statically typed variables. Now we'll take that further. We'll put functions in arrays and we'll pass function as arguments to other functions. Okay. First, here's our function. We can put it into variable and call the variable directly. So first, takes numbers, we define the type. Then we have some function. Takes number, return number. Function, yeah, so that will return 2. We can put the function in an array, then take it out and call it. First, we'll do that using an intermediate variable. Then we'll do it in a single step. So we have an array of functions. Have the type takes number, returns number array, and we put in it add1. And then we take a function with the same type, take it out of there, and then we are calling it, so it will return 3. Array of functions is that one, and it's that one. Yeah, this will do the same thing. We can choose between naming our function type, like takes number, returns number, or writing the whole function type out explicitly. So here is the type explicitly in bananas. So that will be 5. Why did we put parentheses around the function type in type definition? Because without you are missing one. Copy. Change send great day. Send feedback. That's a very different type. It describes a function that takes one number and returns an array of numbers. I see. It takes number and returns number array. That's a very different type, sure. Here's the problem. We can pass functions as arguments to other functions. Passing functions as arguments always feels like a big jump to a human, but from the type checker's perspective, it's just like any other type. Our call function below takes another function as an argument. If the types match, the compiler will be happy. So it is taking f, which is a function, takes nothing, returns number, and it returns f. Okay, so what do you want? I don't see like any invocation here. Oh no, there is a call function and we are calling it with the function inside of that. Okay, so it returns number, so this will return. Yeah, so it takes the function and calls it immediately. So it takes this and calls it, so this one will return 3. There's another one, takes number, returns number. This time we will be increasing, call it 3 or will return 4. The call function above passed a hard-coded argument to f. Instead of hard-coding the argument, that is here the hard-coded argument. We can pass it to call function, which then passes it along to f. So we have a call function that takes the function and the parameter. Then we have the call function and we define the function and provide it with the number. So this will return 2. As is the same thing, but the input parameter is the function and 2, so it will return 3. Next thing, most first-class function types are defined inline, like they were in the examples above, but when the same function type is used in many places, it's often a good idea to name it, like we did for takes number, returns number. It's possible to write functions that take functions, etc. However, it's unlikely that you'll need to do something like that. And if you do, it's probably better to wrap those intermediate functions in objects, where the function is just one property of the object. The functions that take functions that take functions, I see. The next few examples build up a function that takes a function that takes another function, just to see that it's possible. First, we have a simple function that returns 3. Function 3 returns a number, sure. Now we define call function like the ones above. The argument to call function has the same type function. Okay, so this one, call function is that one, and it takes the function which returns number and it outputs a number, and then in the body we just call the function. And now we do exactly the same thing again. We want to pass the call function as an argument, or few function has to take an argument that matches the type of the call function. Oh, that's complicated. So there's a call function with 3 function. So it takes a function which takes a function and outputs number, and output of all of this is a number, and then we return call function 3. And 3 is defined here. Call function 3. Where this 3 comes from? Oh, it's here. Okay, so it takes 3. Returns call function. Okay, I see. That's ugly. That's not very readable. Just to reiterate, it's unlikely that you'll ever be tempted to do this. If you are tempted, there will be other, more readable ways to solve the problem. The type checker doesn't understand whether code is readable, though. It only cares about whether the type match. And we finish. 4 minutes. Maybe I can do another one. Assertion function. We'll probably not be able to do this. What about another one? This one is also long. Cursive types. Okay, whatever. I can start with assertion. An assertion function throws an error unless some condition is true. We'll start by defining the basics form below. In these examples, you can type error if an example will cause an error. When this assert function doesn't throw an error, it will return undefined. Okay, function assert, condition boolean, if not, throw the assertion error. Okay, that one false one, so this will be undefined. Error. This assertion function guarantees that condition is true. You can tell that by looking at it, but Typescript compiler doesn't know that. What happens if we call assert type of variable 1 equals to number? As in the example below, the code after that point will only run if assert didn't throw an error. That means that var1 must we, how do you read that? English. Mastiff. Okay. Or one mastiff actually be number. But TypeScript doesn't know that. It still thinks that it's number or string. Okay. When a code example has a type error, you can answer with a type error. Assert number, so this is error. This is a type error. Well, this no, it will what? What? Oh yeah, it will not throw an error. It will type error, and it is because here we will assign it a number. Here we will check. So this is a true. So it will return undefined. It will continue here, but here it is still this type, the variable one, so we cannot assign it in there, and that is correct. And our timekeeping thing says that we are done. Done is better than perfect, and I will see you next time.